In the last video, we looked at what the basic premise of refrigeration is. So you basically have this liquid that is able to boil at a really low temperature inside this refrigeration chamber. And as it's boiling and forming a gas, it's picking up heat from its surroundings. And this space here, along with your food, cools down, right? So now if you can lead this gas to a point where it can then dump that heat or discard that heat, give the heat back to the surroundings, and in the process condense to a liquid. And then when the liquid is led back into this chamber, it again evaporates, picking up heat and cooling the space down, and then the cycle goes on, right? So that's the basic premise of refrigeration. So now let's replace this simplified diagram with sort of the bare bones or the skeleton of a modern refrigerator. So what I want to do in this video is introduce these major players or these main components of a refrigeration process and give you an idea of what the basic function of each of these components is. So we'll look at the specifics or the details of the workings of each of these components in later videos, even the temperatures and pressures involved in a cycle. But for now, let's look at the functional aspects of these components and also how all these come together to sort of cool your food down, right? So a basic refrigeration cycle involves two sides. One is a high pressure side marked by this darker shade here. That's the portion of the cycle where the refrigerant fluid is flowing under a high pressure. And then you have the low pressure side marked by this lighter shade here. And this is where the fluid is flowing under a relatively low pressure. So those are the two sides of the system. So when you have a cycle like this, you have to start at some point. So let's start at a point that we are most familiar with. That's the cooling unit. That's where your food cools down. It's called an evaporator. So let's zoom in a bit. So what's happening in this evaporator is that the refrigerant fluid, which is at this point a liquid under a low pressure, is absorbing heat from the food and this in the space here in this chamber and boiling and becoming a gas, right? So and it's basically traveling through this coil. And it's important for us to remember that it is a low pressure liquid here at this point, because we know from the last video that pressure is an important knob while considering the boiling temperatures of this liquid here, right? So higher the pressure, higher the boiling point, lower the pressure, lower the boiling point. So if for some reason, because of some malfunctioning parts upstream, if the pressure of this liquid is higher than what is required, it's not going to boil at that temperature. So it's not going to absorb the required amount of heat. So your food will not be maintained at the set temperature in that case. It'll become hotter and hotter inside the refrigerator. So it's really important for the pressure here to be low enough for the liquid to boil and become a gas. So now this low pressure gas that forms here basically travels through this, what we call a suction line, and then enters the compressor. So the compressor is a component that's essentially a cylinder with a piston inside. And the piston is driven up and down using an external motor. So the motor provides the mechanical energy for it to go up and down. So as the piston is going downwards, it creates sort of a sucking action. So the same thing what happens when you're trying to draw water or juice from a glass using a straw. So you're able to pull the water or the juice into the straw and then into your mouth by basically creating sort of a vacuum inside the straw. So the same thing is happening here. So as the piston is going downwards, it opens this valve here, which is called a suction valve, and all the gas that is inside the suction line is pulled inside this compressor chamber. So as the piston is going all the way down, the gas comes in and fills the entire chamber, and at some point, the pressure inside here equals the pressure outside, that is in the suction line. So at that point, the suction valve closes. It is a one-way valve, which means that it's not letting gas go in the other direction, back into the suction line. So, and then the piston starts going upwards. So in its upward stroke, what it's doing is it's compressing this gas here. And as it is compressing, the pressure of the gas and the temperature of the gas go up, because we know from our gas laws that as the volume of the gas is going down, the pressure and the temperature go up. So as the pressure is increasing, this discharge valve opens, and then you have all this high pressure gas that is at a higher temperature than what it was when it was entering the compressor. this escapes and goes into what we call the condenser. So as the piston is all the way up, all the gas from inside this compressor chamber here is going out the condenser. And what's happening here is that the high pressure gas here that happens to be at a higher temperature than the surroundings could be just ambient air of your room, or it could be like a cooling agent, like circulating water. So basically the gas here is at a higher temperature than what is outside the coils, right? So as a result, heat is transferred from inside, from the high pressure gas here to its surroundings, and in the process of giving out heat to the surroundings, it's condensing and forming a high pressure liquid. So it's going from a high pressure, relatively high temperature gas to a high pressure liquid. So you could even have let's say a fan here that will help circulate the air and transport the warm air that is surrounding this condenser coil to elsewhere in your room. So this is basically convection, heat transfer through convection. So speeding up the heat transfer here. So at this point you have a high pressure liquid that's coming out of the condenser. Now and then it goes into what we call the liquid line. Now you have this refrigerant in liquid form that you would think is ready to go back into the evaporator and start boiling. But there's a problem there. So this liquid is under a relatively high pressure, right? So but remember, for it to boil at the required temperature, at a low temperature, you want the pressure of the liquid to be reduced. And that is where the expansion device or a metering device, we also call it the thermal expansion valve, comes into picture. So what this guy does is it basically controls the pressure of the liquid that is entering the evaporator, because we know that the pressure here has to be low enough for the liquid to boil. So it's acting like a flow restricting device that causes a drop in the pressure of the liquid that goes into the evaporator. So we'll look at the details of how an expansion device works in a later video. So but for now, you get an idea of how all these components come together and work to refrigerate your food. So again, the low pressure liquid here that gets into the evaporator is basically picking up heat from your food and becoming a gas, and then is drawn into the suction line into the compressor. This gas is basically pulled through the evaporator coil because of the suction effect that is produced by the suction stroke, the downward stroke of this compressor that sort of pulls the gas through the evaporator into the suction line and into the compressor, right? So as the piston is moving downwards, you have the gas filling it up, and then as the piston is going upwards, it compresses and increases the pressure of the gas, and then also the temperature of the gas, right? So now the high pressure gas here is discarding its heat, or it's basically transferring its heat back to the surroundings, which happen to be cooler than its temperature, and in that process condensing and forming a high pressure liquid that then goes into the expansion device through this liquid line, and the cycle repeats, right? So that is the basic outline of how various components work in a refrigeration cycle.